Graphing a system of 4 inequalities is not much different than graphing a system of 2 inequalities. We just have to draw more boundary lines and figure out which way is the correct side of all of the lines instead of just 2 of them. So if we're graphing this system, I'm kind of looking ahead a little bit at these last 2 inequalities. It says x is less than or equal to 0. That's weird. I feel like that should be greater than or equal to, but whatever, I'll just go ahead and graph what it says. X is less than or equal to 0 means we'd be to the left of the y-axis, and y is less than or equal to 0 means we'd be below the x-axis. This is the line x equals 0, and we're to the left of it. This is the line y equals 0, and we're below it. So that's essentially all these 2 inequalities are saying. We're using solid lines there, and we're shading, or we would be shading on the side that I drew the arrow. So you can see I'm treating those pretty much the exact same as any other inequality I would be graphing. But let's look at these 2 remaining inequalities. First off, 2x minus 5y equals 10. I'm pretending it's an equal sign when I'm graphing the boundary line. And we get, well, let's figure out our x, or when x is 0 rather, let's figure out what our y coordinate is. Well, if this one is 0, we get negative 5y equals 10. Divide both sides by negative 5, we get y equals negative 2. Similarly, if the y coordinate is 0, if that part goes to 0, we get 2x equals 10, thus x equals 5. So we get the point 5, 0. This is nice, it can be much quicker doing it this way, and can actually be a lot nicer to find the x and y intercept than using the slope-intercept form for a lot of these points, which is why I'm doing it so much. Before I actually draw the scale on these axes, I'm gonna plot this, or I'm gonna figure out where the x and the y intercept are on this other line, line 2. That's this one here. X plus 2y equals 8. Because when I'm setting up my scale here, I just want to make sure everything shows up. All of my intercepts can actually show up on my scale. So let's see, if the x-coordinate is 0, then we get 2y equals 8. Thus, when the x-coordinate is 0, we get y. The y-coordinate is 4. And when the y-coordinate is 0, this part goes away. We get x equals 8. So that's the point 8, 0. Alright, so the biggest value among these is 8, so I'm going to go ahead and let's go 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. And 2, 4, 6, 8. Alright, now plotting these points, we have the point 0, negative 2, which is right here, and the point 5, 0, which is over here. This is going to be a solid line. I know that it's a solid line because this is greater than or equal to. And so it's going to look something like this. I'm going to go ahead and label this as line 1 so I don't forget. And for figuring out which way we'd shade, I'll go ahead and test the point 0, 0. Again, we can always test the origin as long as it's not on our line. And we get 0 minus 0 is greater than or equal to 10, which is false. 0 is not greater than or equal to 10, which means we'd want to shade on this side of the line, below it. For the other line, let's see, the point 0,4 is up here, the point 80 is 2, 4, 6, 8 over here. And my line looks something like that, maybe. Yeah, I can do better than that. Let's try this. That's pretty close. Alright, call that line 2. Let's figure out which way we'd shade on this one by testing, you guessed it, the origin. 0 plus 0 is greater than or equal to 8. It's a weird looking 8. 0 plus 0, I'm plugging 0 in both for x and y. We get 0 is greater than 8 is false, which means we'd want to shade away from the origin. So we need to be below this line, we need to be above that line, we need to be to the left of the y-axis and below the x-axis. Well, just looking at these two, looking at lines 1 and 2 here, just between those, I know it would have to be this area that would be shaded. And one approach that you can kind of take when you're figuring out which region should be shaded here is to kind of iteratively take it. Starting off with region 1, all of this stuff satisfies region 1. But then I'm going to cut along here and only keep the stuff that satisfies region 2, so that gives me this stuff here. Alright, well, the line x is less than or equal to 0 is over here. You can see nothing in this region satisfies that inequality, so we would actually in this case say that there's no solutions. I believe, based on that, I believe these were probably intended to be greater than or equal to 0 instead of less than or equal to 0. So, obviously if they're less than or equal to 0, we would say that there's no solutions. If they are both less than or equal to 0. Let's go ahead and flip this around and call those greater than or equal to 0, because I think that that's the way that this was intended to be. Let's say that this is x is greater than or equal to 0 and y is greater than or equal to 0, which means instead of shading to the left of there and below here, I should be shading to the right of here and above here. It's actually quite common that we see these problems when it's x is greater than or equal to 0 and y is greater than or equal to 0, because what that does is restricts us to the first quadrant. And if it's this way, then we end up getting, let's see, so lines 1 and 2, we already knew that it was this region. X being greater than or equal to 0 means we're to the right of the y-axis, which includes all of this stuff. But y being greater than or equal to 0 actually keeps us down to this region right here. So that's the region that will actually make all 4 of these inequalities true. And that's what I would shade here.